On June 13th, 2024, a Tesla in full self-driving mode collided with the police cruiser. So what happened? Well, you might be surprised that the cruiser being at an uncommon sideways angle played a pretty major role. How do we know? Well, through simulation. Let me show you. Let's open up Parallel Domain where we can reconstruct the scenario. We can match environments using digital twin replica locations or procedural locations. Match the lighting conditions, the police vehicle type, the camera configuration, and the key parameters we want to test, like the rotation of that police cruiser. Then programmatically, we can run simulations across all the variations to generate high-fidelity sensor data with the ground truth annotations, including bounding boxes, semantic segmentation, and depth to compare to. We then take the RGB images from this simulation and run it through a perception model to perform simple object recognition. In this case, just drawing a bounding box around the emergency vehicle every frame. Here, we're just using an off-the-shelf YOLO model, but perception teams can run their own model on this dataset. We then compare the two to come up with a mean average precision score, which measures the accuracy of the prediction to the ground truth annotation data. And here's what we found. We found that in the original conditions, nighttime, emergency vehicle lights on, the mean average precision score was indeed very low at 0.05. The biggest difference came from changing the time of day. In daylight, performance jumped to 0.64. The one surprising factor we found was that having the emergency vehicle lights off actually decreased performance for the daylight scenes, but increased performance for night, illustrating just how different combinations of variables can influence performance. And lastly, we measured the performance at multiple car angles. And so while we see very little signal for the night scene, we see some interesting signals for the daylight scene. So let's zoom into that. Here we can see how the performance is higher for the front and the rear of the vehicle, but lower on the sides of the vehicle. And this likely is due to the fact that training data often contains far more front and rear images of on-road vehicles rather than sideways vehicles. So in conclusion, we're not trying to call out any specific manufacturer, but instead showcase the importance of simulation for testing and analyzing autonomous systems.